Hello coders, in this video we will solve fourth question of Leetcode weekly contest. We already solved three questions and this one the hard one, and let me take you to the screen. And yeah, we solved the smallest stable index 1, 2 and multi-source flood field. Today we will solve count good integers, and let's see what question says. Question says you are given two integers L and R and a string directions, okay, consisting of exactly 3D characters and 3R characters. For each integer for each integer x in the range L to R inclusive, we need to include L and R both. Perform the following step. If x has fewer than 16 digits, basically the number which we are taking between L to R has uh, lesser than it is. If it is not a 16-digit number, then pair it on the left with leading zeros to obtain 16-digit string. Basically, what does it mean? What does this mean? Is yeah, should be on 1 minute. We'll see what does each condition means. So first condition, what it was saying, if x has fewer than 16 digit, pair it on the left with leading 0 to obtain 16 digit string. Basically, what does it mean? If we have a number, let's say if we have a number 8, because it is given in the first example, so it will be easy to me to explain. So I am taking 8 number, and it is, since it have just one digit, what we will do, we will add 15 zeros to the left. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and then 8. Now it's 16 digit number with 15 left, like 15 zeros at left and 8. You get it? Now let's say if you have a number which is 1 like 12, then also what we will do, now we will add 14 zeros and 12, like 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, I think I add extra 1 0 here. So doesn't matter. We just need to understand what does that line means. If the number is lesser than 16 digit, we need to add zeros to the left. That what that condition means, or the first line means. Go to the second line. The second line is place the 16 digit into 4 cross 4 grid in row major order. And it's saying you what does mean row major order. The first 4 digit from the first row from left to the right, then next 4 digit the second row, and so on. This is how it works. So to pad 8, what we will do, first 4 it will be on first row, then we have second 4 on second row, then next 4 on next 4 row, then we have next 4 on next 4 row. Likewise, we will obtain 4 cross 4 grid. You get it? Yeah. That's what that means. We need to place 16 digit into 4 cross 4 row major grid. First, we need to convert it to 16 digit string. Then we need to fill it row major. First 4 in first row, second 4 in second 4 row. Sorry, second row. Next 4 in next, like third row, and last 4 in fourth row. Likewise, we will fill 4 cross 4 grid. Then we have third condition, which is this one. It says ki starting at the top left cell, row is equals to 0 and column is equals to 0. Apply 6 character of direction in order. D, increment the row by 1. R, increment the column by 1. It means ki we need to go from 0 0 to anywhere, but we need to follow the direction that we have given in the directions. So basically, what does it mean? Ki if it says D, we need to increase the row, and if it is say R, it means ki we need to increase the column. So what does it mean? Ki we are here, and let's take this string, and First we are at 0 0, that they have given that we will include the 0 0 that in our path. Basically, if we think the direction, we are following a direction in on a path, then the path will start from 0 0. So okay, we are at 0 0, and then where will go? Okay, wait, we will take this directions. We are at 0 0, then it says go down. Okay, we are at 0 0. If we go down, then where will be here, right? Let me give you row number also. Okay, sorry, 0 1. You understanding it, right? Ki we need to go down, it means ki we just need to go the next row, and we need to go R means we need to go on next column. But let me take this 0 1 2 3 4. Okay, no, not 4, 0 1 2 3. First we are at 0 0, then they said D means we need to go down. So if we are at 0 0, we will go down and we will be at 1 0. So we will be at 1 0. Then again they are saying go down. So okay, I will be at 2 0. Then they are saying again go down. Okay, then I will be at 3 0. Then they are saying go right. Okay, then I will be at 3 1, right? Because I was here 3 0 till completed 3 digits. Then I have R. Then I will that R means I have to go one column to the right. So 3 1. Then again I have R. It means ki 3 2. Again I have R. It means ki 3 3. Okay. So likewise we reached till last cell here. Okay. Now we how many cells we have? 1 2 3 4, like 7 cells we have. So this cell, what they want to mean, like why they want to choose those cells, like why they want to choose those direction cells. Let's see what they are saying. Ki, like see at the fourth one, they are saying ki record the sequence of digit visited along the path. Okay, these are the path direction which we have visited. We need to also maintain which digit we visited on that path. So on 0 0 we visited 0, on 1 0 we visited 0, on 2 0 we visited 0, 3 0 also 0, 3 1 0, 3 2 0, on 3 3 we visited 8. Here we visited 8. Okay, what they are saying ki okay, record the sequence of digit. We made the sequence of digit visited along the path, including the starting cell, and produce sequence of length 7. Okay, we have a length 7 sequence, right? 0 0 0 and 0 0 0 8. And what they are saying, the integer x is considered good if the recorded sequence is non-decreasing, means increasing. Not just remember the increasing, but it's not strictly increasing. They are saying it should be non-decreasing. So this string, like not string, this recorded sequence is in non-decreasing order, that we can see 0 0 0 0 0, then 8. There is nothing like it's increase, no, it's an increasing sequence, right? So that's what they mean ki if x is considered good if recorded sequence is non-decreasing. Let me tell you one, like let's consider we have 108 number, which is 108, and if you want to fill it in 4x4 matrix, then how we will fill it? Like this, right? 108, and if we follow the same directions, then we will get 1 year. Now check this sequence. This is not good, cause first we saw ki 0 0 0 till 4 zeros, then we have 1, so okay 1, then again 0, so first it increased, then again it decreased, so it is not good. So now you understood, right? What does it mean ki it should be non-decreasing. Then what do you need to do? Return an integer representing the number of good integers in range L to R. Okay, we need to return number of such integers between this L to R. So whatever we did here, if we code as it is, then it will give time limit exit. Why? Because the numbers can go. They have like constraint are so big, like 10 raised to 15. What if ki L is 0 and R is 10 raised to 15? It's not even solving. We can't even solve it in big of n, right? That hint you are getting here. Though we understood question, like understanding the question itself was the big deal for me. Firstly, when I understood the question, I wrote the brute force method. But when I wrote the brute force method, while writing, I know ki it will take it will give time limit accelerator, because through this constraint I could know ki I can't even solve it in big of n. So there will be something else that I don't know, or you also don't know, that if you don't have solved that. In that case, then I searched, went through the solutions. I didn't solve this in contest. I solved this in I did this upsolve. So I understood one concept, which is digit DP. Yeah, you heard right, digit DP. That we need to understand right now. Like that I have implemented. Then this question got solved. So what does mean digit DP here? So here basically what we do, ki we know dynamic programming, we apply that dynamic programming on digits. So if we have 16 digits, so it will be like 16. For the 16 digit, we will see ki can I place numbers on that digits, and how many numbers do we have? We have 10, sorry, 0 to 9. We have 10 numbers, and on the 16 digit, on if I select one digit, then I can place 0 to 9 any of digit on that place, like on that digit. And this can happen uh, when it's not in that sequence. Like, okay, you understood ki I 16, 10, and now we understood this key. We need to take 16 digit. We need to check 10 digits that I can place on that 16 digits separately, like digit by digit. And there is one thing also, which is tight. Tight means what? Key on that digit, basically, can I take the number? Can I take this number or not? That I need to decide first. Cause see here, key, if I give you ki if they give ki L is equals to 0 and R is equals to 108. So for this, I'm going from 0 to 108, and I need to find good digits. And this 108, for this, if for here, I can take like on the 8th place here. Which numbers I can take? I can take 0, I can take 1, I can take 2, I can take 3, 4, 5, 6, 7, 8, and 9 also, if we don't have 1 year, right? So for this digit, I needed to see ki if I can give, if I can take this number here or not. That you understood now, right? So it is depending on that variable which I am saying type. So it can be 1 or it can be 0. 1 means restricted. It means ki the number which is ahead of the decimal number, it's like here if I don't have 1 here, then I can give here, I can take number 9, right? So that type basically what says ki a number I'm giving here right now, it is basically, if type is equals to 1, then it is basically restricted to this limit. Now another variable came, which is limit. So we need to check limit also here. Ki it is exceeding through that limit or it is not exceeding through that limit. If tide is equals to 1, then I need to check ki it's not exceeding the limit. And if tide is equals to 0, it means I can take any number from 0 to 9. Okay. So yeah, that's what I wanted to explain, the digit DP concept that I learned, and we will use that concept here. While writing the code, I will tell you how we will solve it. Okay, I mean how we can write the code, that I will tell you, like digit DP's code. One concept also that I need to tell you, which is what they have said ki we have 8 digits, like not the 8 digits, 7 digits, because we have 6 digits, 6 digit directions, and through that direction we maintain 7 digits. From like 7 digits we have maintained, and what we want, those 7 digits we want that should be in increasing order. So what we need to do here, we need to maintain like limit also, like not the limit, I'm saying a type for the digit, like how much till till what number I can take here, like how many numbers I can, numbers digits we can say 0 to 9 digits, not digit or numbers, okay we can say the number, uh, we can take which number for the digit to maintain that we maintain type. And also uh, for for this question, as we want it is in increasing order, what we will do, for that index of that string we will convert it to the string, and for that index of the string we will maintain that digit should be greater than or equal to the last digit I have visited, or I want it should be in greater or increasing order. It should be in limit and it should be in increasing order. That two condition we need to implement. So let's see how we can implement. I implemented it, and I bet you will also understand. I'll write clean code, and you will know this key how digitdb working here, and digitdb work here, but like how it how it was easy. Okay, once you know the digitdb concept, it's all about it. So let's see to the screen, and yeah, what we will do here key we will, through the digitdb we will find all the increasing number from 0 to r, and then we will subtract numbers from 0 to l minus 1. Okay, so to maintain digitdb, that I said ki I want 16 digits, so I will say ki I have a dp of 16 digits, in which I have two variables, which is this. I will say ki this is in dp, and I have 16 digit. 16 means 16 the length of the string that I'm saying. 2 here means it is a type or not, for that I'm taking, and the type or not, how many numbers I can take for that digit. It will be 10, right? Based on the type I can limit it, but max value of number that I can take for the digit, it can go to the 9. So 0 to 9 I can take 10 numbers. Okay, so yeah, I took this. So now I need to what I need to do first. I have L and I have R, but I need to convert it to the string. So what I will do, okay, I will do that later. First, what I will do, I have a directions. So I will first I will go and I will see which direction, to that direction which indices I'm getting. So I know there will be only 16 indices. So I can say I have a vector of path of 16 indices, path of 16 indices, and for each indices right now I don't have any limit, like every it's non-titled basically. And then what I will do now I want to see on which digit I have to apply the type, right? So what I will do r is equals to 0 and column is equals to 0, and right now I'm at 0 column, sorry, 0 at 0 cell. And as they have said we will have just 3d and 3r, it is basically saying we will not go out of 4 grid or take na, or we have 3d, so we we will we will go down just 3 times. We have a 3r, so we will go just 3 times to the right. So to get the indices, what I will do for characters in that direction, in the direction vector ch, that direction. I will say ki if that character is equals to D, then I have to go down. So I have to increase my row. I will say R plus plus, and else if it is not D, it means it is R, and I have to go. I have to increase my column. I have to go right. So C plus plus. Okay. Then what we will do? Now we have the cells, row and column, and that cells, row and column. Basically here, if we take in row, we took in row major order, right? So the index in the path for that cell will be 4 cross, like for first row R is equals to 0. For the second I have to uh, go for the first, like we have to skip for first 4 indices, then I have to go for fifth one, right? So likewise what I will do ki 4 cross R, basically it means ki uh, at which row it is I need to do 4 cross R plus C. So basically it will give index for that cell in that string, and I have to say ki path of that index is equals to 1. So it basically means ki no, I have type for that index. Okay, I have limit for that index. Basically it means ki I have to keep these indices in increasing fashion. The value on that indices in increasing fashion. Now what we will do ki I have dp, I need to first I will say ki all values are -1. So there is function that is memset. I will use that memset dp. I'll fill -1 to dp dot size of dp, and what I will do ki okay, now I did this. Now I will calculate from 0 to R, and for that I need to fill the first condition, which is if there are not 0 I need to add zeros to the left. I will do that. How I will do ki I will just convert string s is equals to string R, and I will take en, that is string size, and I will say ki one temporary string to fill it to 0. Temporary string, I will fill the temporary string with 0. And how I can do that? Temp dot insert. I'm using inbuilt functions. You can also use such things. Sn, I will fill it with 0, and okay, Sn with all zeros. And what I will do key, now I have to take both string. So I will say take first string, and yes is equals to first pair zeros, and then apply, like take my string. Yes is equal to yes, or 10 plus yes. Now I have to solve it. Wait a minute. Hello again. Where we will solve from there. Yeah. So we took yes is equals to 10 plus yes. Okay. So what was the insert function? This we will start from 0 till yes n, that is till this, not this yes n. We will say 16 minus yes n, that these are the remaining zeros that we have, that the remaining size for the 16 digit that we have, and till this size we will fill zeros, and we have yes is equal to 10 plus yes, like now we have a 16 digit number and we need to solve it. So solve it for and the solve function will return the number of good x or good numbers in that 0 to R. So I will say it is long int count of R, which is solve for this string, start from 0 index and take the start from 0 index. I have this, and then I have path variable, and I will say key for 0th index type is right now 1, or I can say I am at 0th index and type is 1. Take this path variable Yeah, all it is. Then what we will do, we need to perform the same things for R. Let's say s is equals to string l minus 1, because we need to subtract till these numbers from R. S is equals to string l minus 1. Again, sn is equals to s dot size, and string temp nothing, and temp this, and we will do this again. So before doing this, we need to fill the mem set for l minus 1. There will be the different numbers on that digits, right? So yeah, basically you can take it right, like I have 19 and I have 190, or 90 and 190, not 90 190. Okay, take it like mm, I have 10 and I have 200. So for the decimal digit, I have digit for the left I have one limit, and for 200 I didn't have any limit, like it was a zero, like I have the limit of 0. So basically for that we need to fill the dp again, and we will solve it till l minus 1, that we converted the s, and yeah, it will be long l, and we will return count r minus count l. So now we will write solve function. Write the solve function. Okay, we took this 10, right? So basically it means that the last digit we have seen, for like we need to maintain the last digit that we have seen, right? Because we need to maintain it is in increasing order. So that we need to include here in this question, like in this solve function. I will say the last digit I have seen right now it's 0 basically, and for here also I will say it is 0. I am at 0th index, and last digit I have seen it was the 0, so I can take num numbers according to the path, or oh yeah, according to the type on that digit. Or okay, I'll write the function, which is long solve. First I have so first I have index, then I have string, or at first I have string. Okay, first I have string here. Okay, let me take this whole here. Let's see, and yeah. So what is this? Yes, is a string, yes. Then I have index. Then I have one means what here? One means the type. So I did type this. Then I have 0 means what? It was the last digit that I have seen. So I enter last digit, and the path was the vector one. Vector int path. String also I can take as the address. So we will not copy like the same string again and again. So I will take its index, its address only. Where does it go? Path, and okay. Now what I will do, if my index is equals to 16, it means I am at the last index of the string, and I completed the whole string, and that I completed the whole string between that constraint. So I will return one that okay, this string is in that constraint, that it is the good string basically, that's what we were counting, right? So I constructed this string, it means, and I'm at the last index, it means I constructed it in good way and return the one. And what I will do, if I will use my dp user, if for that index, for that type value, for that last digit, do have it, if it is not equal to -1, then I will return it as it is. As it is means what, I have already calculated for such things, for such scenarios, so I will return it. Okay, now what I will do, I will say a limit, like at what limit I can increase my digit for that, I can increase my number for that digit. Okay, or I can increase my like 0 to 9, which number I can take for that thing only. So what I will do, I will say I have a limit variable. Limit is equals to, right now I will say it is 0, and I will say if my path is equals to 1, or not a path, but I will say my yes at that index, or I can itself, here itself I can do this, yes at that index minus 0. When I need to maintain this, like if it is tight, so I can say I am using ternary operator here, if my tight is equals to 1, then do this, like yes at that index and 0. Otherwise I can take any 9 values. So I will do this as ternary operator here, just, and nothing else. Okay, and then yeah, for index digit is equals to 0, digit is less than equal to limit that I took, and d plus plus. What I will say, if I need to maintain the increasing sequence for that uh, index of that path, like if path of that index, not every index we need to maintain, right? We just maintain that 7 digits, like that 7 sequence number. All numbers can be in any order, like all numbers can be in any order, but that those numbers should be in that sequence only. Basically it means that uh, yeah, if the path at that index is equals to 1, then what I need to do, first I will declare one answer variable, that which is long answer is equals to 0, and answer is equals to, I will say answer plus equals to solve the function, solve this function. And before solving, what I will do, if that digit it is greater than the last digit, then and then only I can take the digit, right? Because it is already said path at that index is equals to 1, so we need to maintain it. We need to maintain it is in increasing order. So what I will do, if my digit is greater than or equal to last digit, then only what I need to, I will solve it further. Solve for solve s and index plus 1, and which number, like what I will, then type value will be variable here, like a type value will be depend on if that limit is equals to my yes at that index, like basically that will be the limit, right? Yes at that index it is my limit. So tight value right now, like tight value is basically before I had a tight, then if now I have a tight, in that case only I will pass it, otherwise I don't pass it. So what I will do, if I will say type, I have seen the type, like for this function do I have a type, that I have to put the type, and right now do I have a type, t is equals to limit. If it is, then it will pass 1 to the next one, like for the next one, otherwise it will pass 0, and path we will pass it as it is. Okay, and then what we will do, if path index is not equal to 1, so basically it means I can take any index. So I will take this. In that case also we need to maintain the type 1. Okay, and then while returning I will say return dp at that index for that type variable, and for that last digit is equals to this answer I had. Okay, so run it. So your B, sir, how much expected 5, but there are 4. Right, okay, last digit, the last digit that we are seeing here, it is D, and here also we are taking the D and last digit, like D from 0 to limit, and so that we will take, and R is equal to 0. Okay, they, oh shit, so basically it is confusing for him, like for that compiler key which are you are mentioning. For each equal to D, then I will increase my row otherwise I increase my column, and to get that index I will say 4 cross row and add column, and yeah, now it looks fine. Temp, string temp. Okay, I'm redefining or redeclaring it. Temp. Okay, now let's submit it. Oh, it's giving the wrong answer. Why? Use this test case and we'll see why. What did? What happened here? The digit we are taking, that we were passing here, but the things we need to do is there you are. Here. Things we need to do here is this. We need to maintain just last variable of our sequence, so we don't need to pass d, we need to pass the last one. The last one was maintaining the digit at the of that sequence, not every digits. So yeah, so that was the thing. And last d, and let's submit it. And yeah, it's again giving the wrong answer. Okay, use the test case. I think I used something like here. Instead of int, I should have used long because it is now submit it. Now it's giving more answers. Like how? Oh, my paths 0 equals to 1 because I am taking first always, right? Always I am taking the first one, right? So my path 0 equals to 1 and then run it and submit it. It is accepted. So yeah, this was the hard one question where I learned digit DP, and you also learned right now. So yeah, well, and the time complexity for this is big of 1 only because it is just 16 cross 2 cross 10. We are checking that one, and for the 2 string, so basically it is just big of constant time, and space complexity is also 16 cross 2 cross 10. And yeah, so that was the question. We'll meet in next video. Till then, bye bye.